So we got an electric field is a region of space which an electrical charged particle object would experience a force. So if we had a particle in the middle of the field, it's going to experience a force in that field. It's a vector field, so we can use arrows, and we need to make sure when we draw the field that we follow the rules, I suppose, that are used everywhere that Faraday established. So there's three things about drawing an electric field that you need to be aware of. So electric fields flow from positive to negative. What's another thing? They never cross each other. So electric fields lines don't cross. And at what angle do they leave a particle? At right angle. So what would happen to a positive particle in this field? It would go towards the charged surface. You could draw it on here, and it would be drawn by the electric field force towards the charged surface. We have electric field strength given by E for electric. So field strength is the force per coulomb. So what's the formula? F over Q. And our previous lesson, what was the force equation? So we've got the force formula divided by Q, so we're just left with 1Q on top. So you all remember this is equal to what? Good job. Good memory. And Q is the charge causing the field, and R is the distance from it. So let's calculate the electric field strength 0.5 meters from a positive charge of 3 coulombs. Any thoughts what to do? Epsilon. So Q R squared. So we just discussed this is equal to Q is correct and R is, put it into the calculator, see if you beat me. 1.08 times 10 to the 11. Units are newtons per coulomb. Correct. E equals F over Q. Force equals E times Q. 300 times what? What's the charge of an electron? 300 newtons per coulomb times that coulombs. Get rid of the coulombs, you're left with newtons. 4.8 times 10 to the negative 17. Newtons. And it's a negative force. Okay, next one. Calculate the force experienced by particle B. That times Q1 times Q2 divided by, good job. This number is, everybody? Q2 is, R is, tricky question, 0.05 because we want it in meters. I don't know. All right, let's do some diagram drawing because we're art students. We've got two particles. First particle, second particle. So remember, it comes out of at a right angle. And then as it goes towards this one, what's going to happen? It's going to deflect away, right? Because they're both the same charge, positive, yeah? All right, the trickiest question probably for today. Calculate the electric field strength midway between the two particles. The electric field strength halfway, so it's B minus A. Or A minus B. But we're going to use vectors to figure out which way it's going, right? And the radius is halfway. So what's half of 5 centimeters? 3 coulombs divided by 0.25 squared. That's A. And then B is exactly the same, except we're using 2 coulombs. So A is going to the right, B is going to the left, and we get, when we subtract both of those, we get those two going that way with N per C.